So what if we need to simplify radicals that are not perfect squares? That's what we're going to talk about today. And the truth is that it still goes back to perfect squares. So the first thing we're going to do, and I want you to do, first of all, we're going to use the page 16 as notes today and examples. So get that out. Be sure you have that out. Go through that with me. And then your homework is actually going to be in the book. So I know I'm throwing a little spin on things here, but you guys can handle it. So first thing we're going to do is write down our perfect squares. Whoa, that is a really fat marker. Okay, so write down your perfect squares along the side here. 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared, 11 squared, 12 squared, 13 squared. Let's just do 14 squared and 15 squared. I don't even know if we'll need that far. Okay, so what if we don't have perfect squares? What you need to do is break it up into a factor that includes a perfect square. So, for example, this first one right here. Am I even? Yeah, I'm recording. Okay. So 20 is not a perfect square. However, 20 breaks down into 4 times 5. Does it break down into 2 times 10? Absolutely. But there's no perfect square there, so that doesn't help us at all. We are looking for factors that include a perfect square. So once we have done that, now I can use my product rule to put that into the square root of 4 times the square root of 5, right? And then the only one that I'm able to simplify is this one, because I can remove the square root sign and make that a 2. Now, this is how we would write the final answer. This is like saying 2 times the square root of 5, but we just write it, with multiplication glue, and that is as good as it gets. Okay, so we're going to do a bunch of examples of this. Follow along with me. Square root of 18 breaks down into, yes, it breaks down into 3 times 6, but that doesn't help us. We want a perfect square, which is what that 9 gives us there. Okay, so we break it down into the square root of 9 times the square root of 2, and then we can take that out of the radical sign, and it becomes a 3. Nothing else we can do about the square root of 2, so we leave it. That is simplest radical form. Okay, you guys are going to get really good at this. So let's look at 32. What are the factors of 32? Really what you want to do is go down through this list of perfect squares and find the biggest factor that goes into 32. 4 goes into 32, right? But also 16 goes into 32. And that is bigger, and so that's the one that we want to use. We want to use square root of 16 times the square root of 2, because I can take the square root of 16, and it becomes a 4 when I remove, take it out of the house there, and I'm left with 4 square root of 2. That is my simplified radical form. Okay, so let's continue. 500. What are the factors of 500 that are perfect squares? Again, the biggest factor, okay? 4 goes into there, but that's not very big. 25 goes into there, but that's not very big. 100 goes into there. So I'm going to rewrite this as the square root of 100 times the square root of 5. And that's going to give me, what's the square root of 100? 10 square root of 5, okay? So I want everybody to think for a second about 24. Take a look at your list of square roots. What's going to go into 24? The biggest number that can is the 4. So I'm going to break this down into my factors of square root of 4 times square root of 6. And I'm going to get to square root of 6. Okay, that's not a perfect square. That has to stay that way. So 50 is going to break down into square root of 25 times square root of 2, giving me 5 square root of 2. Okay, you can do 8 on your own. I want to jump down here and look at this square root of 80. Now, they did something a little bit funky here. You can do it this way. They broke it down into prime factors to find it. I'm going to encourage you to continue to use this, method of looking through the perfect squares and even using a calculator if you need to when you get to some of these bigger numbers to see which of them go into there. In this case, we can break this down into let's see, maybe let's say you don't know that 16 goes into 80. Okay, let's say that this is going to get a little messy here because I don't have a lot of space, so just bear with me. Let's say that you think, okay, well, 4 goes into there, right? 4 times 20. So I'm going to like swing this over here so there's enough space. So now I'm left with 2 square root of 20. You have to be able to recognize that I'm not done, that there's another perfect square that can come out of 20, which we actually did up above here, right? So you have to be able to recognize that this is actually like saying 2 square root of 4 times square root of 5, okay? And then I can take that square root of 4 out of there is 2, so it's essentially 2 times 2 square root of 5. And then I can simplify it further to get 4 square root of 5, which is the answer that they came up with. Okay, they just did it a little bit different method. And had you from the beginning done, I'm going to switch down here, had you from the beginning known that 16 goes into there, then you would have gone right to this. 16 times 5 is 80. And so the square root of 16 is 4. Radical 5. Same answer. But if you don't know that, it's perfectly fine to use this blue method up here that I did with the 4 times 20. You just have to go all the way with it. Okay? So if you get to a number like 162 and you're like, I don't know what factors go into there, you might just need to use a calculator and start trying a few of them until you see that 81 is going to go into there. Okay, so it's going to be the square root of 81 times the square root of 2 equals 9 square root of 2. Let's see what else. I think you guys are probably getting the hang of this here. 108, I don't know. Let's see, what's going to go into 108 here? 108 divided by 64, maybe? Nope. 108 divided by 36? Yep. Okay, so I break this down into 36 times 3, and I get 6 square root of 3. Okay, this is what you're doing for all of these. Now I'm going to give you some homework from the book. If you want to continue to practice on this page a little bit, you're certainly more than welcome to do that.